Alright, this is Precalculus lesson 7-3. We're talking about multiplying and simplifying rational equations. So simplify. This word is a little bit different than when I say simplify an equation. So when I have a rational function, when I say simplify, that means get rid of the removable discontinuities. So when I do that, I need to factor this thing. So essentially simplify, if I can rewrite this, it's factor and cancel. So factor and cancel. Although if you do simplify, the graph suddenly will not be correct because you're getting rid of the whole. So can someone factor the numerator for us, please?
X plus 6 times x minus 1.
X minus 1, perfect. And arrow, you want to do the bottom? And x, I'm going to do plus 6 first so it looks better in my notes. But yeah, so that's going to be a difference of squares. So you multiply the conjugates. Perfect. So when I say simplify, now I'm going to actually get rid of the removal of discontinuity, which is these two terms. Just they cancel out because the same thing's on the top and the bottom. And I'm left with the simplified rational, which is x minus 1 over x minus 6. So now whenever I say simplify, you know what I'm really asking for. So multiply. So when I need to multiply rationals, and I'm trying to remember if this does come up on the SAT. I feel like simplifying rationals comes up quite a bit, multiplying less often, if at all. So let's try this one. X plus 1. It's going to be a bunch of polynomials here. Let's do x squared plus 2x minus 3. And we're going to multiply that by another rational function. Let's do x squared plus x minus 6. All of that divided by, we'll do a negative x squared plus 2x plus 3. Alright, so when I say multiply, I guess really what I'm asking for in these instructions is to multiply and simplify.
Just a heads up, everyone, the internet is down. It may be down for quite some time, we're not sure. So not everyone will have internet for quite some time. We'll let you know when we're back up.
So it wasn't just me, alright. I'm glad I grabbed my SAT questions before the internet went down. So when I say multiply on the instructions on the test, it usually means multiply and simplify. It rarely means don't simplify. So you can always assume this, and if I say otherwise, then I'll explicitly say that. All right, so how do I do this? What do you guys think?
Just like normally multiple fractions?
Yeah, exactly. So yeah, you multiply straight across. So this top times that top, that bottom by that bottom. That gets really ugly really fast because x times 1 times x squared plus 6, or plus x minus 6, that's going to be something with an x cubed in it, right? So you could do that. The easiest way of doing this is to factor first and then multiply, because then things might cancel out. And usually they do. That's the trick that I'll throw in on the test. If they don't, that's just really cruel and unusual punishment, I think. So I'll try to avoid that. X plus 1. Arrow, you want to do the bottom for the first fraction for us? And then Ben, get working on the top right, and then we'll do race for the bottom right, or maybe Mr. Sindel can do that one. X plus 3, x minus 1, there it is. Ben, you have the numerator in the second rational function.
X minus 2 times the quantity of x plus 3.
X minus 2 times quantity of x minus 3, well said. X plus 3, sorry. Alright, and then Mr. Sindel will do the bottom one. So I don't like negatives in front of the x squared. It makes it harder to keep it factored, to get it factored. So I'm going to factor out a negative 1 to begin with, and then that's going to be x squared minus 2x minus 3. And in your notes over here you can say, well, I don't want to rewrite everything just so I can factor that bottom right. So that thing factors to x minus 3x plus, x minus 3x plus 1, x minus 3x plus 1. All right, and then your fun part, getting rid of things. So anything that's multiplied on the top and the bottom, you can get rid of. So what do we see here? We have an x plus 3 on the bottom left and an x plus 3 on the top right, so you can simplify those out. You can cancel them out. I see an x plus 1 and an x plus 1 as well, so an x plus 1 on the top left and an x plus 1 on the bottom right. Is there anything else that we can do? I think that's as much as we can get. So our final answer, after we cancel out a bunch of things, well, yeah, we'll leave this as a final answer. We'll leave it as x minus 2 on the numerator, and then on the denominator it's going to be negative 1, don't forget him. We'll have an x minus 1 and an x minus 3. I have multiplied them together. It is still in factored form. I did not say whether I wanted it in factored form or non-factored.
Can you just do negative? Gives you a negative 1?
Explain what you mean by that?
So do you have to write the 1, or can it just be negative on the bottom?
You could just write a negative, yeah. And that is the answer that I'm looking for. Usually the easiest form is the best form, so I'm just going to leave it like this. And let's talk about how much notes do we have today. We might need 2 more slides. I'll copy this just in case. So let's talk about advanced multiplying. Advanced multiply, which isn't really advanced, it's just a different form. So let's give ourselves our example, which is going to be 3x divided by 4x squared, and we'll multiply that by 4x cubed over 21. It's still rational functions. I guess not really for the right-hand equation. This is not a rational function because there's no variable in the denominator, but I can...
Is that 21?
It is 21, yeah. Do you guys already know how to do this? You can try it on your own. I'll give you guys a few minutes to think about it. Oh, let's add in another one. Let's make it even harder. I'm realizing that I forgot the other one in my notes. Times 14 over 4x to the 5th. In the notes on the side, I'm going to put usually no negatives. No negative exponents. If you're wondering whether or not to keep something on the top or the bottom. Oh, whoops. All right, so I'm going to go ahead and go through this. So when I'm multiplying, I'm really just taking the entire top. So this is going to be 3 times 4 times 14 times x to the power of 4. So I'll write that out. 3 times 4 times 14 times, and I just combined all the x's When you multiply, you're really counting the number of x's. So there's 1 here, 3 there. So there are a total of 4 of these x's. And again, on the bottom, I have all the numbers 4, 21, and 4. 4 times 21 times 4. Count the number of x's. 2 there, 5 there, for a total of 7. And then you get to start crossing things off after you get to that point. So we have a 4 and a 4. And you can kind of simplify a little bit. This is the way that I show 4 and 14 reduce. So I do an arrow in the 14. And I say that reduces to 7. And this 4 reduces to 2, because I just kind of simplified the fraction 14 over 4. And then you'll see that 7 and 21 will also reduce. So I'm going to, again, I'll use a different color to show what I'm doing. I'm going to cross out that 7. And I don't even need to do an arrow because it totally crosses out. So cross out the 7, and the 21 now gets reduced to 3. And now you can see that the 3 and 3 cancel each other out. 3 and 3 cancel each other out. So that was simplifying all the numbers. There's probably a few different ways to do it. That is the way I do it. You do not have to do it my way. As long as you get the fact that all of those numbers cancel each other out, you're good. And then finally, you're left with simplifying your exponents in your x. And you usually do the bigger number, subtract the smaller number, and stay on the side of where the bigger number was. So the bigger number is on the bottom, so 7 minus 4 is 3. You leave it on the bottom. So your answer is 1 over x cubed. Did we make a mistake in here somewhere? We did. Do you guys see it? It's this guy right here. This guy right here. We forgot the 2. So yeah, there's just a lot of reducing. Just try to keep track of it. Even I made a mistake right there. You guys will probably make mistakes too. Maybe a better way is making these arrows go to the bottom for the denominator so you can see that they stick out so you don't forget them. All right, and then let's do dividing. So I think you guys have probably heard of this before. If you haven't, that's awesome. So there's 3, I don't know why I went to 1 to 3. There's 3 mini steps here. And the expression that I always like to use is keep it, change it, flip it. Keep it, change it, flip it. Whenever you divide fractions, divide rationals, these rules come up over and over again. So let's look at an example. I'll do it on the right over here. Let's do x minus 4, all of this divided by x minus 2 squared, x minus 2 quantity squared. And I'm going to divide that by x squared minus 3x minus 4 for the numerator, and the denominator is going to be x squared minus 4. It's kind of weird that we have a random bell right in the middle of class, but okay. So yeah, keep it, change it, flip it. So what I mean by that is keep the first fraction the same. So I'm going to rewrite that first fraction, x minus 4, and I'm also going to factor, wait, that's already factored, we don't have to do anything, x minus 2 quantity squared, and change it. What I mean is change this sign. This sign was a divided by symbol, and now it's going to be a times symbol. So we change it, and then we're going to flip it. We're going to take the reciprocal of our fraction over here, and at the same time, we can factor this thing. So normally I would put x squared minus 4 on the top, but factored, that's going to be difference of squares. You guys want to just shout that out?
X.
Ooh, careful.
Plus 2.
Oh, yeah.
Yeah, x plus 2, x minus 2. And then x squared minus 3x minus 4, that's going to factor to what?
x minus 4 times x plus 1.
X minus 4, x plus 1. There it is. And now, it is a little bit hard to see in our notes that that was the reciprocal, but hopefully we can follow that. Let's start crossing things out. We have an x minus 4, x minus 4. We have an x minus 2 and x minus 2. So the way that I do this when there's x minus 2 to the power of 2 is I cross out the 2 and cross out this one, because that lets me know I'm left with one of the x minus 2's left. And then your final answer here, after crossing everything out, is an x plus 2 in the numerator, and we'll keep the denominator factored. X minus 2 times x plus 1. And the symmetry of our notes would not be the same if we didn't have advanced dividing. So let's throw that into there, and then we'll be done. Ooh, this is going to be a good time to practice our order of operations. So let's do 2x divided by x cubed divided by 3 divided by x squared, or 3 over x squared, and divided by 4x. Alright, I'll let you guys work on that for a few minutes. Alright, so when we solve this thing, we need to keep it, change it, flip it. We'll just worry about this first order of operations first, because if you remember from PEMDAS, you always go left to right. So I'm going to do this left operation, and then I'll worry about the right operation. So it's going to be 2x over x cubed. Now keep it, change it, and then flip it. It's going to be x squared over 3. And now everything here is, you can think of this as one giant block. So what we're going to do is we're going to keep this, change this, and flip this. So when I change it and flip it, this was 4x over 1. Now it's going to be 1 over 4x. So really the shortcut is whenever you see a divided by symbol, always just change, flip, change, flip, change, flip. You don't need to always do the keep, change, flip with order of operations. So when we do that, we get all the numbers on the top multiplied to 2, all the x's on the top multiplied to x cubed. On the bottom, all the numbers multiplied to, I'll just leave it as 12. I think that's probably easiest. And then all the x's multiplied to x cubed. Sorry, not x cubed, x to the 4th. And when we reduce, the 2 gets canceled out. The 12 goes to 6. And I'm going to cancel out the 4. That's going to go to 3. And all of the x's get canceled out. So I am left with nothing on the top, 1. On the bottom, 6x. Perfect. That is the end of our notes. Go ahead and do your summaries.